Welcome, Namaste. Welcome to the first episode of Spin Care. Spin Care channel, we are actually planning to bring in a lot of topics of interest for the spinners and the spinning industry, where we will be discussing about the latest technologies, reviewing latest technologies, and what are all happening. In future, we also plan to bring some good debates and discussions about the textile industry, especially spinning sector. So we welcome you to the first episode of Spin Care. Today's topic is very interesting. The topic is do you need inverters? VFD in H plants. VFD means variable frequency drive. So the thing is, it has become a trend now to install variable frequency drive or inverters in supplier and return air fans. Many plant suppliers have started incorporating it and giving it as a standard also, thereby increasing the cost. And some existing plants which do not have variable frequency drives in supplier fan and return air fans, there they are installing it. The main reason is to save or conserve energy. They say by installing these inverters or VFD, you can save energy. The main question is, does it save or conserve energy? Is the VFD really required for supplier and return air fans? Before we decide to install VFD on supplier and return air fans, we should understand the design of H plant. H plant is commonly known as humidification plant, which is actually HVAC, high volume air conditioning. Typically, in India, H plants control only relative humidity and not the temperature. In order to control the temperature, we need to install a chiller plant. While designing a H plant, we need to take the following into account: volume of the department, heat load, exhaust air volume, required relative humidity percentage, required number of air changes. These are the critical data which actually affect your process if it is not properly designed. The process will be in control if, according to the fiber, the relative humidity and number of air changes are designed. Volume of the department means the height of the department up to the fall ceiling, the length and width of the department will give the actual volume. Heat load is the machine load as well as the human load over there, lighting load, everything considered. Then the exhaust air volume. Every machine exhausts a lot of air, especially over the motors. So that quantity also is to be taken into account. What is the required RH? Say in blow room, it is 65% usually. From carding to ring frame, it is 55%. In case of compact, you may go as low as 50% or 52% also. And number of air changes required, it is specified for each and every department. So say for a typical ring frame department, it can be 3940 air changes, for example. So with these critical data, we can calculate the required CMH of conditioned air. What is CMH? Cubic meter per hour. That is the air thrown into the department through the supply air. Okay. So how much of air should be thrown? That can be calculated from these above data. In order to meet the CMH requirement, we should select the fans which can deliver the required CMH requirement. So once the CMH is calculated, we should select appropriate fan size in order to deliver the required cubic meter per hour. The fan size, blade angle will determine the required flow. The fan size is basically what is determining the required flow, that is the capacity, CMH. and the blade angle is adjusted accordingly in order to fine tune and optimize and correct it. Okay, once a fan is selected, motor to drive the fan also has to be selected. As the motors are not tailor made, they are available in standards and we have to select the nearest size. Say, for example, for a particular CMS, a fan has been selected and that fan needs a motor to be driven. A motor comes in standard kilowatt ratings, say 15 kilowatt, uh, 17.5 kilowatt. Then the next step is 22.5 kilowatt, then 27 kilowatt. So say you want 19.5 kilowatt, there is no standard motor. You have to go to the next step. Okay, say 25 kilowatt. You cannot put a 22 kilowatt motor. You have to go to 27 kilowatt motor. So the kilowatt rating has to be higher because of the standards. So we may not be able to match the exact kilowatt required because motors are not tailor made. And in other cases, will be slightly over capacity. The fans will deliver more CMH with the selected motor, as motor is never tailor made to the required capacity. So at 50 hertz, if it is supposed to deliver a particular capacity, so still it will be generating that, but the motor rating is more. So the current consumed will be also more. Hence, we need to change the blade angles to deliver the required CMH of air. Once the fan is selected, the nearest motor size is selected, then we have to make the blade angle proper so that the required CMH is supplied. So when we use a VFD or an inverter, we can set the fan to deliver actual CMH by reducing the frequency. That is, by reducing the frequency, fan revolutions without changing the blade angle. This will result in some power saving as the fans are supposed to operate 24 hours, 365 days. Once the setting on VFD is optimized, the frequency should be fixed and not changed at any cost. Changing the frequency for further reduction of energy will affect the production process as it will affect the number of air changes in the department, reduce the CMH, and we can see more breakages, lapping tendency in the department. The production losses, efficiency losses will be much more than the energy saved. Quality deterioration, fly and fluff in the department, working conditions, etc. will result. VFD will not actually save any energy unless the fan itself is over designed. Only in case of the fan over design, the VFD will save some energy. In order to save or conserve energy, engineering department or the utility department, without the process knowledge, will do more harm than good, as experienced in many mills now. Many mills, they have gone with this VFD, thinking that it will save energy. And the engineering or utility department, they want to reduce the electricity bill. So they go and they reduce the frequency, thereby reduce the revolutions of the fan. And thereby the CMH is totally affected, the air changes are disturbed, and the department is totally deteriorated. Why this is happening? Because the engineering or utility department has no idea of the process or of the fiber material, how it behaves, what are the conditions it requires. So many mills who have gone with VFD are now facing these issues. Where exactly is VFD useful in H plant? We need VFD or inverter in air washer pump. This will save a lot of energy in the pumps. It will ensure required RH percentage and once achieved will reduce the pump speed accordingly and result in better control of H plant and department RH and also conserve energy. And as a standard, now everyone is giving inverter in the pump. VFD is also required in waste collection systems of blowroom, carding, and Kumbar. This is one area, one place where we need VFD and mills are ignoring the same. And The suppliers are not giving VFD for waste collection systems. The radial fans in the waste collection system is supposed to ensure the suction pressure as per recommendation of the machinery manufacturer. For example, if the required suction pressure is 800 Pascal and the radial fan connected to a set of cards is delivering more suction than required, VFD will reduce the frequency automatically with a closed loop feedback arrangement using a pressure sensor and save energy. See what exactly is happening. You require 800 Pascal, but you find out after installing it is delivering say 1000 Pascal. So that means there is scope. You can reduce the speed and achieve some good energy saving there. At the same time, when you take it up for cleaning or maintenance, one or two cards can be stopped. When it is stopped, you don't require to even generate the minimum required pascals. So that time, if there is a VFD or inverter, it will automatically reduce further and save further energy, provided it is designed in such a way that there is a feedback arrangement. What is the actual Pascal now available at the cards? So what we require is only 800. So if two cards are stopped, it may again shoot up to 900 or 950. What will happen? The sensor will give a feedback to the inverter. The section pressure is high, you can still reduce. So it will further go down, reduce the frequency, and it will save the power by maintaining 800 Pascal, which is actually required. The same is true for even Kumbers also, or even in Lorum also. So when you install VFD on radial fans of the waste collection system, that is where exactly you are saving the energy, not on supplier and return air fans. Say if you add one or two if one or two machines are under maintenance or breakdown, the required suction pressure is less, so inverter and VFD will reduce further the frequency and save energy. If one or two cards are added to the existing group of cards, say you are doing a modernization thing, or you are replacing the existing cards and you find you have space, you can accommodate one or two more cards or one or two more Kumbars, mills will be forced to replace the existing radial fan with higher fan capacity because the number of cards has increased or the Kumbars has increased. So the Pascal generation has to be more. The suction pressure required is more. What happens? The each plant supplier will say, "Sir, this radial fan does not have that capacity, so you have to go for the next radial fan. So you need to buy a new one and scrap the old one, which is a costly affair. It's a capital investment again. But if you have a VFD installed, we can increase the frequency and accommodate additional one or two machines. So what happens one or two card or one or two Kumbar if you are installing additionally? If the inverter is running on 50 hertz, so you can make it 55 hertz or 58 hertz or even 60 hertz, and that will be more than sufficient to take care of the suction. So you need not replace the old radial fan with a new radial fan. But if more machines are added, then the inverter cannot handle. Then in that case, you have to replace the radial fan. Okay. In conclusion, I want to say variable frequency drive on supply air and return air fan is not advisable because you really don't save much of energy there. And the major issue is the engineering or the utility department people, in order to conserve energy and reduce the electricity bill, they will reduce the frequency, thereby disturb the entire department, which will create more losses than what the energy is saved. But if you already have installed it, then optimize it and freeze it. Whatever frequency you are getting the required air changes and required CMH, required CMH. So that is the point. Say if your current plant is running at 50 hertz, maybe at 49 or 48 hertz, if you have achieved the required CMH, you have to freeze it there and it should never be tampered or changed. in any season. People think in winter we can save, in rainy we can save. So there are different concepts in different geographical locations. So that should not be done. The moment you start tampering it, the department performance will deteriorate. There'll be more breakages or lapping tendencies and a lot of lie and fluff generation inside the department, which will reduce your productivity levels, which will affect your quality, and it doesn't give any savings. And I doubt if it can give you a proper payback also. So it is not advisable. And if the suppliers as a standard are including these inverters in supplier and return air, you can ask them to remove them and reduce the cost of the inverters they are putting. And VFD is definitely required for air washer pumps and radial fans of waste collection system of blow room, guard, and combers. This is an area where you can really save substantial amount of energy. So instead of going for VFD on supplier and return air, you should go for radial fans of waste collection systems. And of course, definitely air washer pumps, they are already giving it, and you can retain those VFDs on the air washer pumps. So that is my opinion. And you can send your comments. And I request you to subscribe to this channel. And also, we welcome your suggestions because we will be discussing various topics related to latest technology available in our spinning. Whatever is being launched, we'll be comparing the features and all. And at the same time, there will be many more debates and discussions related to spinning in the coming episodes. We may also have some interviews with prominent textile technologies and leaders in the industry. So we also welcome your comments and suggestions. Kindly subscribe and share this video. Thank you.